Okay, so in this lecture, we'll cover this concept of functional classes. So this is basically part of the language of organic chemistry. So I think a lot of organic chemistry, a little bit like a foreign language. There's a lot of terminology that you have to know. If you want to do really well in organic chemistry or just chemistry in general, you have to understand the terminology that's used. So this one related to functional classes. So this basically just describes what is in a molecule. What is an oxygen in the molecule? Is a nitrogen in the molecule? So if you understand the functional classes and the terminology, then you understand something about the structure of a molecule. Okay, so if you have a molecule, so starting from the left, that just has carbons and hydrogens in it and nothing else. So it doesn't matter if it's 1 carbon or 100 carbons. If it's just carbon, hydrogens, and nothing else, and it's got the maximum number of hydrogens in it, that's what's known as an alkane. If you had a molecule with a halogen in it, and again, it can be 1 carbon or it could be 100 carbons. So it doesn't matter what the halogen is. It could be chlorine, could be fluorine, bromine, or iodine. So if it's got a halogen in it, it's called an alkyl halide. Right, the alkyl meaning alkane, and the halide meaning that it's got a halogen in it. Okay, if you have a molecule with a carbon-carbon double bond in it, then that's called an alkene. So it doesn't matter if it's 1 carbon-carbon double bond or 10 carbon-carbon double bonds. If it's a ring structure with a double bond in it, then it would be so cyclo, meaning it's a ring. And alkene, the ENE basically tells you that it's a carbon-carbon double bond. If you have a carbon-carbon triple bond in a molecule, then that's called an alkyne. So again, it doesn't matter if it's 1 carbon or 100 carbons. If it's got a triple bond in it, that functional class is called an alkyne. And so the YNE is what tells you it's an alkyne, a triple bond. Okay, so a molecule like this with the 6 carbon ring and 3 double bonds in it is called an arene. Right, so if it's only got 2 double bonds, that's a cycloalkene. To be an arene, specifically this arene is called benzene. It has to have the 3 alternating double bonds in it. Double bond, single bond, double bond, single bond, double bond, single bond. So that's an arene. Okay, so and I'm kind of organizing these. There's a pattern to them, organize them in terms of similar reactivity. Okay, so if you have an alkane chain and the molecule has an OH in it, so specifically it's got carbon, oxygen, hydrogen, then that's called an alcohol. If it's got a carbon, nitrogen in it, then that's what's called an amine. And so the nitrogen could have 1 hydrogen, it could have 2 hydrogens, or it doesn't have to have any hydrogens on it. So if we had this molecule, that is also an amine. So it just basically has to have carbon attached to nitrogen. Okay, if you have a carbon sulfur hydrogen in the molecule, so that would be the key component. Carbon sulfur hydrogen, that's called a thiol, sometimes called mercapto. More trivial name, but the thiol is the technical name. Okay, and so those will undergo, so alcohols, amines, thiols will undergo some similar reactions, but they do also have their own specific reactions. Okay, a molecule like this, where you have a carbon, oxygen, carbon, is called an ether. And if it's a sulfur instead, so a carbon, sulfur, carbon, is called a sulfide. If it's an oxygen between two carbons in a 3-membered ring, then that's called an epoxide. Also sometimes called an oxyring. So it has to be three-membered ring. One of the atoms in the ring has to be oxygen and the other has to be carbons to be an epoxide. So those all have similar reactivity. Okay, so if you have a molecule with a carbon-oxygen double bond and a hydrogen attached, then that's what's called an aldehyde. So it has to be carbon, C double bond O, hydrogen to be an aldehyde. And it doesn't matter what this carbon is. It could be a 1-carbon chain, it could be a 100-carbon chain. So if you had a molecule like that, where you have a carbon, and then a carbon-oxygen double bond, and then a carbon, that's called a ketone. So sometimes, since the carbon chain can be whatever, sometimes you see it just generalized, R. So R means alkyl. So for all of these structures that I've drawn so far, you know, it could be 1-carbon chain, 100-carbon chain, so we could just call it R. R means any carbon chain. Okay, if you have a carbon-nitrogen double bond, and the nitrogen could have a hydrogen or another carbon attached, doesn't matter, then that's what's called an imine. And if you have a carbon-carbon double bond with a nitrogen attached, and then the nitrogen can have 2 hydrogens or it could have 2 alkyl groups. So that's what's called an N-amine. So the En from the alkene, and the amine because of the nitrogen attached to the double bond. So to be an N-amine, again, it's got to have a carbon-carbon double bond with a nitrogen attached to it, and whatever else is attached to the carbons and nitrogens doesn't really matter. Okay, so if you have a carbon-carbon double bond with an OH attached, then that's what's called an enol. So the En is from the alkene, and the Ol is alcohol. Has an alcohol attached to an alkene, that's an enol. So a specific kind of this enol would be an OH attached to an arene, and that's what's called a phenol. All right, so we covered the arenes here. So an arene with an alcohol attached is called a phenol. So there's lots of functional groups in organic chemistry, so we're not done yet. There's a lot more to go. So let me just sketch these out, and then we'll name them. Okay, so these molecules. So this is what's known as a carboxylic acid. So to be a carboxylic acid, the molecule has to have a carbon-oxygen double bond with an oxygen attached and a hydrogen attached to the oxygen. And it doesn't matter what's on the other side of the carbon-oxygen double bond, any alkyl group. Okay, so if you have a C double bond O attached to a Cl, and it doesn't matter what's on the other side, any alkyl group, then that's what's called an acid chloride. This is what's known as an anhydride. So to be an anhydride, you have to have a C double bond O with an oxygen and then another C double bond O, and it doesn't matter what the alkyl group is on the two sides of the C double bond O. Okay, so this is what's known as an ester. So to be an ester, it has to have a C double bond O, oxygen, and another carbon. Or we could just generalize this R and R. So it doesn't matter what's on the left side of the C double bond O, and it doesn't matter what the alkyl group is attached to the oxygen. And so you might notice sometimes, you know, it gets a little tricky if we had a molecule like this. Right, that's still an ester, it's just drawn backwards because it's still a C double bond O attached to an oxygen, which is attached to some alkyl group. So that would be an ester. And this one is C double bond O. Doesn't matter what the alkyl group is that's attached to nitrogen, and it doesn't matter what's attached to nitrogen. It could be hydrogens. Nitrogen wants 3 bonds, right? So one of the bonds has to be to C double bond O, and the other bonds on nitrogen can be hydrogens or any alkyl group. And that's what's called an amide. Okay, and this last one, if you have a carbon-nitrogen triple bond, and it doesn't matter what the alkyl group is attached to triple bond, then that's what's called a nitrile, or sometimes called a cyanyl group. Okay, so let me just write a few examples and then see if you can identify what the different functional classes in the molecule are. Okay, so if we take these molecules, so what is the functional? So you'll see this on the first exam. I'll just give you some molecules and ask you what the functional class is in the molecule. So this first one is an alcohol, right? It's just got, so that's what makes it an alcohol. It's got a carbon attached to oxygen, which is attached to hydrogen. And this next molecule is an aldehyde. Right, it's just drawn backwards from the way it was drawn here, but to be an aldehyde, it's got to have a carbon-oxygen double bond that has to have a hydrogen attached to it and an alkyl group attached to it. Right, so you have a C double bond O that's got a hydrogen attached and a carbon attached. That's an aldehyde. Okay, so this will just be an alkyl halide. Right, because you just have a halogen attached to an alkane chain. This would be a ketone. So if you notice, it's K-E-T-O-N-E, it's not K-E-Y-T-O-N-E. So don't draw it like that because that will drive me crazy. So part of organic chemistry, again, is knowing the language, and knowing the language is know how to spell things. So it's K-E-T-O-N-E. So why is this a ketone? So you have a C double bond O that's got 2 carbons attached to it. Right, you got C, C double bond O, C. Technically it's a cycloketone, but ketone is good enough. Okay, so this one would be, so you have a C, C double bond O, O, and another C. Right, so that would be an ester. Okay, let's try a few more. Okay, so what are the functional groups in this molecule? So this first molecule, that would be belong to the class of molecules called carboxylic acids, right? Because it's got a C double bond O with an OH attached. And then again, it doesn't matter what the R group is. In this case, that's the R group. All right, so that would be a carboxylic acid, just drawn backwards from the way it was originally presented. So this next molecule actually has 3 different functional groups in it, or 3 different functional classes. All right, this first one, that would be a ketone, because you have a C double bond O, C. This would be an alkene, and this would be an amine. If you notice, this is not, it's not an enamine, because the nitrogen is not attached directly to the carbon-carbon double bond. So it's just an amine and an alkene. Okay, so 3 different functional groups in that molecule, or functional classes. Okay, and then this last molecule, so first of all, it's not an arene, right? That's not an arene because it doesn't have the 3 double bonds in it. It's just a cycloalkane, but that's not a specific functional class. So this part of the molecule would be a ketone, and this part of the molecule would be an alcohol. So 2 functional groups in that molecule, ketone and alcohol. It's not a carboxylic acid, because to be a carboxylic acid, the OH has to be attached directly to the carbon of the carbon-oxygen double bond, and this was attached 1 carbon away. Okay, so that's your functional classes in organic chemistry, at least the ones that we'll cover in Organic Chemistry 1. There are others, but we'll save those for Organic Chemistry 2.